Yeah, it's true. Okay, I'm not where I wanted to be this morning as usual, but I want to discuss further, if you don't mind, the discussion we started about parameterization and the adjustments I made because of one second. Took now. Sorry, I'm trying to compose my screen before I share. I'm no, this one. Okay, and I'm far from done. It's work in progress, but this is okay. Share screen now. So one conversation we were having is about what is a composite claim and is the argument a composite claim? And there's a problem with that because Bentley made the argument that, which I accepted at the time, that we will need composites outside the argument because of complex formula. I still think complex formulas are absolutely something that needs to be thought about, and but I realized that this argument also applies to the argument as a whole. The complex formula ties a bunch of claims to a conclusion. And so the argument as a whole has all these composites. See, the composite is not, the composite has a sense within the argument. So really it is the argument that is a composite in some ways, and yet it isn't. Okay, sorry, I'm not being clear. Let me start from scratch. I think we have something that is, let's call it a model. And here it could be a dynamic model, it could be a causal model, but we have something that says, given this situation, this is the situation I expect in return. But it's a formula, a situation formula. And the situation is presumably multivariable. And I think that here, the key intuition I'm trying to get across is I was very much focusing on the combination of atomic claims in the situation. But really, what we're speaking about is a combination of variables. We have a bunch of variables, some of which are the truth values of claims, some of which are other things, such as parametric values. CO2 is in this range or in that range. And those are variables and their input in a formula. And if this claim is true and the CO2 is in that range and this other claim is false and this other thing is in that range, then we can expect this other downstream variable to be in that range, or this impact to happen or not happen. Again, truth value as a possible output. Yes.
Could we say that basically a claim would be Boolean logic, or like would be a Boolean statement, and a claim with parameters would be a statement in first order logic which also evaluates to a Boolean in the end?
Yeah, I think the output is very much something I don't want to be a Boolean, because I want probabilistic estimates at the output.
Right.
As a free.
But it's this way of thinking, like basically the parameterized claims contains quantors and therefore can contain like relational operators like lower than, greater than, and so on.
Absolutely. The way I'm trying to model it is not making a fundamental, well, I'm pondering, and I'm still haven't reached a conclusion. I'm pondering making, hi James, we're speaking about parameterized claims and how to model them. And yeah, the distinction between purely Boolean claim combinations or parameterized claim combinations. And the question I'm asking myself is, are functional parametric models a totally different object on which we can base claims, right? We can say,
James came in here and he's been wanting to have the parameterized claim discussion for
yeah, I'm
a
trying to
long
do that.
time. Can I at least like give him a quick definition of what that is?
That's what I'm trying to do, but you have your own definition, but go ahead.
Well, I think there's a simple one before getting into bigger models. But the problem with the parameterized claims, right, is when you have a claim that say has a number, like a good example is how many jelly beans, not how many, but like there are 10,000 jelly beans in this jar is a claim, right? And then somebody makes a claim there are 9,999 jelly beans in this jar, right? They're obviously two distinct claims, and yet they have a lot in common. One thing is they're mutually exclusive. Only one of those can be true. The second is that arguments for one either oppose the other or also support the other, right?
Right.
Because you could say like, you know, I took this photo and the computer simulation came out with 9,999 that supports only the one and opposes all others. But on the other hand, if you say that, you know, the bottom half has 6,000, therefore it has to be more than 6,000. That's going to support any claim that is more than 6,000. So there's kind of this kind of set logic and way of arguments influence each other, right?
Yeah, very interesting.
Yeah, so what like parameterized claim is essentially, the claim is there are X number of jelly beans in the jar, and that's the parameter is the X, the number. And so you have however many variations of that people think, and then relationships.
Cool.
Yeah.
Thank you.
You're right, because I was going too much for I tend to always reach for the complex case, and you're right to bring me back to the basic case. Then these are the basic claims, and I said a lot of this can be, and this is what I'm trying to model here. You know, we have a variable which probably has a domain and has a value which can be an entity, a literal, or a range, and the range could be the whole domain. And it's bound if it's got a single value. But the really interesting question is that basically we can say, is this valuation of the variable, this is not just a variable, but a variable valuation, is this contained in another valuation? Like if it's if I say, there's between 9,000 and 11,000 jelly beans, and somebody else says there's between, there's exactly 10,000, is that contained in? Or somebody says there's between 990 and 10,010, that's also contained in, it's a subset. So that's a Boolean value, but there's also the overlap. And I'm thinking of having the overlap be a float, because if we're thinking of probability ranges, I would like the overlap operator to give me a probability, like what's the probability of overlap given, you know, probability distribution is one option. Another probability distribution, what is the common intersections surface, if you will. That's maybe too advanced, but the notion that how much do these things overlap? Do they overlap at the fringe or do they overlap at the core? Maybe normalized by the smallest surface. Anyway, I'm looking at this notion of variable overlap. That's at the entity level, right? But at the higher level, once you have those variables, what's an argument at this higher level? And I haven't written it down yet. But what is cool is once you have overlap on variables, you can ask for a claim. What's the structure? What's invariant over all variables? And I thought, oh, I can model that separately, but I'm thinking maybe not, because it depends over what you may want to vary. Like when you're doing a certain comparison, you're varying certain things. And when you're doing another comparison, you're keeping some variables constant while varying other variables. Because, by the way, this is a case, we're speaking a lot about numeric variance, but there's also entity variance. And I said, entity variable earlier. Sometimes we're saying, oh, I often take the bribe case. John gave $1,000 bribe to Mary. Well, it wasn't $1,000. It was $2,000. That's a numeric variable. It wasn't James who gave it. It was Jack. So that's another kind of variable for the same basic scenario. And is the variant of who gave the money, is it a fundamentally different claim, or is it a variant along another axis? And I think this will be, I don't think there's a right answer to this. It depends. It's with respect to a given query. We're interested in what's the basic structure, what are the variables and their valuations, and I'm working on that. But sorry, that's work in progress. But the notion that
can I jump in here for a sec, because I have a question.
I'll just finish the sentence.
Yeah,
finish the sentence.
Interrupt your train of thought.
What are all the other claims that have the same structure with respect to varying those variables? Okay, go ahead.
Thanks. So yeah, I can get how there's entity variables and variation with who gave the bribe, or to throw something else in there that I find really interesting. Just as a side note, this wasn't exactly what I wanted to address, but I think it might be worthwhile to mention is, was it a bribe or was it a gift, or was it, is
Absolutely.
it, because bribe is a label, obviously, and it refers to people's inner worlds, like their intention when they gave it and their expectation and things like that. So, I notice in the news a lot, there's a lot of disagreement about what people's inner world was like and the importance of it and stuff like that. And you can never prove that, obviously. So it's just kind of like if you trust the person or want to think the best of them or whatever. So, but what all that
in French we call this procès d'intention. It's trial of intention. Like what was saying, oh, this person had this intention in taking this action. We'll never know.
Yeah, that was, anyway, I don't want to go on that, but although it's fascinating to me. So what does this come down to in terms of like an argument map? And I know you're working on the model and everything, but just as a conceptual for me, I'd like to kind of start, or at least have an anchor there. I wonder if you have an idea how it lays out, or a UI, so I can kind of understand how the nodes would be organized. Is that something you have in your mind already?
I don't have an answer. I have bits of an answer, but I'm not ready to talk about it until I've solidified the model. Sorry, I will punt on that.
I can try to tackle that a little bit, maybe at least to kind of get you on the same page of confusion as us, right? The same level of slightly reduced confusion. But what my answer is actually what it will not be. Because I've tried to map these sorts of things in our current in debate map, which is our most advanced tool right now. And debate map, I don't know if you played around with it, but it looks like an argument map, right? It looks like a mind map or something where it's nodes and arrows and stuff like that. And I tried to map our classic example of, is it worth doing the lockdown? because it compares the economic damage to the lives that would be saved, right? And that's one that has this parameterization where no, the damage will be 1 trillion, the damage will be 10 trillion, et cetera. And what that looks like in an argument map that doesn't support this advanced feature is you essentially have to make the same argument over and over again every time somebody adds a new version of that number, right?
Yeah,
so
that's not,
you get the
yeah, that's the entire reason of this conversation, is to avoid that incredibly
right.
uncomfortable. Yeah.
So the first step I would say is that what it should look like is essentially you add the argument once, and based on the type of argument, it is automatically applied to everything else. So the first step would be recognizing that these are parameterized versions of the same claim. With that, you probably have some sort of umbrella thing it might be in the question form. What is the economic cost to a full lockdown of 9 months in the US or something like that? And then you have all the parameterized versions that are out there that people want to propose, and they could add their own. It's a lot like what I call the problem solution space, which is here's the problem, what are the proposed solutions, right? Which isn't our typical dialectic space of only true false claims. You have a node that can have lots of possibly mutually exclusive claims underneath, right? I could see how it works in terms of scoring, right? So where would you place these arguments, right? You would place them in the place it makes sense to place them as much as possible. So when it's an argument that it's 10,000 because I counted them all or something, that would be an argument supporting that one parameterized version of 10,000.
Mm-hmm.
If I know it's not 10,000 because I already ate 10,000 of them or something, right? Then that's an argument specifically against that one. Actually, that's a bad example because it's actually against every one that's below 10,000 as well. But let's just say, yeah. And that's specifically against that. Now, you have things you need to think about, which is the scoring, right? How does that affect scoring? When it's a true false claim, it's easy because the pros increase the, shall we say, acceptance score or the truth of that thing, and arguments opposing it decrease, right? But when you have mutually exclusive claims, I would imagine an argument that supports specifically one claim automatically reduces the acceptance of all the others proportionally.
Oh,
right?
That's interesting.
Yeah, the more you say it's 10,000, the less it can be anything else because they're mutually exclusive.
Mm-hmm.
Similarly,
which I think can be handled by the overlap, by the way.
Like, yeah, and then I can't visualize exactly where you put. I could visualize like a tool that you open up and make the argument. It's at least 10,000 because something, right? And it would have to know you're making the argument against the parameterized group. And when you go view one of the specific claims in that parameterized group, like it must be over 10,000. Then when you look at 10,000 or less, you see it as an opposing argument. And when you look at the above 10,000, you see it as a supporting argument. So it would be a trick of UI. How it would be modeled, that's a separate question. But as a trick of UI, you would want to see that same argument applied in different places according to how it matches with that set logic.
Yeah, okay. So I'm getting a better idea. So you'd have a node, which would be parameterized. So it would basically be like an umbrella or a nested group of claims that are all parameterized. And then under that, it would be basically one collection. And then under that would be a bunch of nodes that would be attached to the umbrella. And they would have a different relationship to each of the nested specific claims, basically. So you'd reuse all those nodes, reasons or objections, and they would just change from like reason to objection, and they'd change in like how strong they were or whatever in terms of scoring.
And just like in a simplified case, forget all the other stuff. At the very least, you have a problem with if it's 10,000, a claim says it's 10,000 and another claim says it's 9,999, you automatically are going to have somebody make the argument, it's not 10,000 because it's 9,999. And so, and then the other person's going to say it's 9,999 because it's 10,000. And you create a loop. It's not a tree. It is a circular graph because yeah, exactly. That's one of the main reasons to have a mutually exclusive relationship built into the model.
Yeah, which would be the zero overlap in my tentative model. I'm just as a point of methodology, I think we're trying to focus on use cases and like what are we trying to express? And I'm not saying UX questions are not important. I think they're extremely important, but they may be premature because I expect there will be multiple. I expect there will be multiple UXs to express these things. I don't think there's going to be one right answer for the UX, and making sure that it's possible to express this is important. And I think that some of the discussion I think is totally perfectly relevant because the fact that I don't know how to express this because it's too confusing. It's like, well, is it possible to express this is a perfectly valid question, and making this expressible is a valid use case. But saying, yeah, the UX, I think it's premature. I think
I'm just trying to anchor some of the features that you're talking about with like a practical example. That's all. It's just trying to better understand overlap, for example. So
that's a perfectly valid question, but I'm trying to think it more in terms of use case and intent rather than how it will look like. It's what problem are we trying to solve is really an important question, and keep asking it. How will we solve it? We may not know at this point. That's a distinction I'm trying to establish.
I think I get it. Yeah. Okay.
But yeah, the question about I think we agree the question of parameterized claims is extremely complex, and we have to be able to have umbrella claims that can compare versions with different parameters. And at the claim level, there are versions with ranges that are compatible, incompatible, overlap, don't overlap, are contained in one another. I think those are basic things. I spoke of it for variables. I think it's true for claims. The notion of saying this range is a sub-range of that range, and hence it's fully compatible, it's fully contained in, that's an important relationship. How to represent that, I'm still, well, if it's a numerical value, we can just draw a line and do the ranges. I think in some cases, if it's really a numeric parametric thing, we may want to actually represent the visual parameter range. It's probably the simplest way to do it. When we're speaking about Booleans, then we're better with different rows, but I think I'm totally considering crazy stuff like parallel coordinates or whatever for complex parameter spaces. But I don't know. I mean, what will be legible? But if we're speaking about numeric, we have numeric. But one thing at the higher level, at the argument level, because that's where I was trying to push, when we are speaking about a parametric model, saying, here's the formula that given these values for these input variables gives this range of value for input variables, range of value for output variables. So that's a formula with probability distribution, whatever, if we go there. Or if someone goes there, really, because it's supposed to be pluggable. Then you can base claims on that. You can say, well, I expect the input variables to be here. That formula gives me this output range to be there. And I'm using that model as a support for a generic argument that these set of input variables should give these set of output variables. And that's our traditional argument. And here we're saying we are using ranges in the claims, which are kind of instances of the generic variable, saying, well, these are the value range of the input variables and value range of output variables. And that's a more classic argument. I expect this will happen because of this. Now, is this formula model itself, is it distinct from the argument, or is it supporting the argument? And this is where I'm still hovering, because I really like the idea of being able to isolate what I used to call a row in the truth table, which is now basically a subspace of the input variable range space, value space, and say this maps to that, and being able to isolate that as a claim. Like, I think this input-output combination is plausible. That's the equivalent of my old truth table rows in a parameterized space. But its underlying machinery is the whole formula. And the whole formula, there's no question that it's multiple input value, perhaps even multiple output values. So the question about where does the composition happen? And the really interesting case is that when we're compositing claims, we're saying this combination of this claim and that claim and that claim, what we're really compositing is their variables. We're saying, because when we compositing claims, some of the variables are unified, right? If f of x and g of xy and z of y, well, we're reusing variables. And when we're just looking at fgh, they all have these variables which exist independently, and when we're compositing them.
Can you give me an example of that?
Yes, sure.
Thanks.
When we were speaking about visualization of this in the last parameterized call, I said there's something called, it would be probably useful from a UI standpoint to have dimension reduction. And for example, we spoke about greenhouse gases. So we said, if CO2 is so many megatons, CO2 in the atmosphere, right? And then we spoke about methane. Well, actually, the greenhouse effect of methane is different than CO2. So if we speak of tons of CO2 and tons of methane and tons of this other greenhouse gas, we're comparing apples and oranges. What we want to create is a variable, which is the greenhouse effect of whichever, and then say, well, if the greenhouse effect from CO2 and the greenhouse effect of methane and the greenhouse effect, so we're dealing with a single variable, which is easier to visualize than thinking about methane, because what interests us is on one axis.
I don't see that as being a problem with the model here. I think that's the kind of thing that people always do. So in the case of lockdown, right? What you have to do is equate human life with economy, right? With money. And how do they do it? They always end up doing it by converting everything to dollars, right? So there's a dollar value on human life. That is the way it's done generally.
There's an equivalence factor, and that's one of the variables of the system.
Right. And that is how you would formulate the claim, right? You can't really do a mathematical comparison, which is, greater than, equal to, less than, without using the same numbers, right? The same units.
Well, in this case, it happens to be linear, right? The formula is not always linear. But yes, I agree. In this case, it can be, we can use an equivalence factor because we have a linear, we suppose a linear equivalence relationship.
Right. Yeah. You would have to make mathematical conversions until you get scalar comparable units, essentially.
Yep.
Yeah.
Which is not always possible, but it's important. The notion of decomposing in linear factors or nonlinear factors, I think, is extremely important. Like if, for example, CO2 and methane interacted in such a way that the total greenhouse effect wouldn't just be, you know, some constant value times CO2 plus some constant value times methane, but also some other value times CO2 times methane.
No, I mean,
squared.
what I would see this coming out to in a debate would be the measure that you're using would be the temperature, average global temperature. That's what people would end up doing, and you wouldn't really compare CO2 versus methane. You would compare strategy A to strategy B, and based on all those other complex calculations, how we see the global temperature range ending up.
Yeah, in a basic model, absolutely. And then somebody comes up with a more complex model where you look at the decay rate of methane versus CO2, which is totally different. And it's a totally
but it would still
story.
plug into, like, you know, what's the global temperature 100 years from now, right? And that's just one sub argument of the global change problem, because it's like, well, you know, also, how does this affect society in general? You know, societal collapse. What if 100 years from now it's 2 degrees C, but in one of those cases it leapt up for 5 years to 50 above that, and everything fell apart, right? So that I see as coming out in competing claims that would be more general. Like you'd say has the best temperature at 100 years from now and doesn't result in collapse of civilization along the way, right? You would refine your claims as you go. Yeah.
And there I agree totally with you. The question, the important question are the bifurcation points, right? We have this generic formula that does this generic prediction, and we say, hey, guess what? In this set of conditions with business as usual, as we say, we lead to collapse. And we need to bring this below that, or this below that, or this below that, so that we're in a non-collapse scenario. Stephen?
Yeah, sorry I arrived late, so I don't have the full context, but I just want to verify something. So the purpose behind this, why you would want to model this, if I understand correctly, is to be able to calculate what is true, right? Like which outcome is true. Is it to calculate a chance of something being true? Is that the use case?
Good question. My aim is still to represent arguments, but in this case, it's about representing an argument that uses such a calculation. So a bit of a caveat here. So the calculation is a bit of an external system, but I want to represent that calculation being used as an argument.
Yeah, because I think it's I think I disagree that to represent the argument, you need to represent the calculation. That's why I'm asking. I understand that if you want to do the calculation, of course, you need to represent the calculation, and that's a goal worthwhile pursuing. Yep. But you know that that's just why I'm verifying. What's the main use case here? Calculating the outcome, but representing the argument.
Valid question. We always said mathematical models would be external and pluggable. And I agree that the system has to work without a causality model, and I'm with you on that. But on the other hand, I think such models are used in arguments, and I want to be able to represent the fact this is a variant. You know, this claim is a variant based on different parameterization of the same calculation. For example, I'm looking at this scenario from this engine and that other scenario from that engine, and I'm comparing them, but I'm using the same engine. Oh, here I'm using a different
but you're using a lot of words that people don't really use in everyday argumentation. That's why I bring up the point.
That's absolutely true.
I think as any discussion we have, I think it would make sense to have like a concrete use case again, where you would apply this, and then we can see like what language should people use, like how would we formalize it, how do we calculate, etc.
It's true that I'm using the climate change arguments a lot, where we have complex nonlinear dynamics and all that jazz. But I do think the same argument applies to Tim's basic example about economic value of lockdown, economic cost of lockdown versus life saved. So yeah.
Okay, well, it was just an observation. I was wondering.
No, it's a valid one.
I would register here that I'm more on Steven's side, that at least until let's say for now, I would be happier just putting that in the same category as evidence, right? Where it's an external piece of information, and people propose that this model proves that, and then people debate whether or not that piece of evidence is a good piece of evidence and how relevant it is, that sort of thing. In order at this stage to keep the model simple enough and move on. And I think that's the sort of thing that is so complex that it would take time for us to fully absorb anyway through practice, and then enhance the system later if it seems to be
right.
the right thing.
The thing that I'm trying to do here, because I think it's important, is we want to have this notion that claims are variant one of another, like variables are variant one of another, claims are variant one of another. And in a way that's going back to James' question on UX, right? What do we do when those claims, what do we tell the user when those claims are variants of the same scenario? And we started this discussion months ago with the notion of posit, where it was variation of truth value. This happened, this didn't happen. Well, in the case of numerical factor and parametric claims, or for other variant scenarios such as whodunit variants, I gave the example of who gave the bribe. There's variation on the bribe amount, but there's variation on who gave the bribe, and it's the same basic scenario, but here there's a discontinuous variable in who's the entity who gave a bribe. We have a basic underlying schema, and we have variation in either numerical factors, truth factors, or actor factors. And there's a way in which we have a very clear idea that we're speaking about detail variation in the same fundamental thing. And who gave it, maybe a detail or not a detail, and that's very much case-based. And this is why I'm saying what are the variant claims, structural family, like other claims sharing the same structure? Well, it depends on which variables we're willing to let vary and which we want to keep constant. Yes, Stephen.
So I understand, and as usual, most of your arguments are about modeling what is. But I think you need to be careful, because modeling what is not modeling what are necessarily useful use cases. So even though I agree with the theories of Boolean and posit and stuff like that, we can model it as like that, and it's meaningful to model it that way, in the sense that it's a more formalized way of modeling what is. But doing so doesn't necessarily mean that that model is useful to support use cases. So because something is doesn't mean that it supports use cases that we actually want to support as part of interactions. That's why UX is always so important. That needs to be supported by CDL. So the question then, if yes, they are variants, then what use cases revolve around these variants that create the need to formalize these variants to the degree that you're suggesting here? That's the question we should be asking, I think, to determine whether or not there's a need to introduce this modeling.
No, absolutely. It needs to be supported by use cases, but I think Tim gave the use case, damn it. I don't feel I have to justify what's already being justified.
But the use case there sounded to me, and that's why I introduced it like that, to be able to calculate the outcome. And that's fine. That's the use case I understand, and you have to model.
That's not my use case. No.
Okay, then maybe can Tim maybe reiterate on the use case then?
Expressing the relation between claims that vary on parameters. What is the relation? And
why do you want to express it?
Because
I think the important part is you end up duplicating a lot of claims in order to express that. So instead of having $500 and $1,000 and $1,500, you have to have 3 separate full arguments to represent that variant.
Mm-hmm. So I think the thing is, the confusion here is there's 2 separate types of modeling or variation that we're talking about. There's parameterized claims, which is a way of capturing a relationship between claims, similar but distinct claims, right? And that's all about the modeling. And then there's talking about mathematical models that's
distinct, yes.
proves an outcome or something, that calculates an outcome. And this is what I hear from Stephen, and I agree with, which is, when it gets to the point, essentially you're using deduction or math to prove this model is true, therefore this thing, therefore this claim is true. When you start proving one thing with another based on the model inside, it gets to me outside the realm of argumentation.
I said very
prediction
clearly,
or calculation.
I said very clearly, this is a different bounded context. It's an external subsystem, and it can be used as an argument in our subsystem.
Right.
But it's not. I agree. It's non-core. I'm very clear on that. I don't know how hard I have to scream it, but it is a separate subsystem. Yes.
Yeah. The question though is, should we be focusing our design time essentially on this non-core external system?
Okay, and the question is, what is the overlap with our bounded context? Because I think there's an overlap. It's a separate subsystem, but some parts of it are actually related. Like when we're speaking, all the talk we have about different rows in the argument table and decomposition into disjunctive normal form, which I think are germane to our problem space. I think they're another form. I'm saying there's a relation between.
So can I try to put this into words of a use case? I think, are you saying the use case you're seeing is that the connection is the claims are about jelly beans and numbers of jelly beans.
Yep.
And the model itself is a calculation of jelly beans. And so the connection between domains would be an argument that this model, therefore whatever the outcome. It would be a generic, this model, therefore outcome. And then you would be able to plug in stuff to the model, and it would determine essentially for you, since you believe the model, what is the best, most likely outcome. Is that it? It's essentially an automated argument.
Maybe. No, okay, this is too much using the external subsystem. No, let me rephrase it.
Let me
close. It's getting close. Let
me try to visualize this in another way. Let me just try to visualize this in another way that makes more sense to me in terms of argument maps, right? Because my idea of using stuff as evidence is that evidence is a very static thing.
Yeah, but let me rephrase it, because I think
let me finish here.
I think you're in a fast trail, but go ahead.
Yeah, I here, because here's something I've never even thought about or expressed before. But
okay.
Let's say that the argument is that a weather model proves it's going to snow. I believe it's going to snow because I agree with this weather model, and it says it's going to snow. Okay, that's a month out. But that weather model keeps getting updated every day. By integrating this external thing with the argumentation, that argument is going to be updated every day as new weather data comes in, and it updates itself, and I don't have to. And then basically, because I agree with the model, I come in someday and see I no longer agree. Essentially, it's going to snow because things have changed through inputs. Right, is that the use case?
It's not the use case I was proposing. It's a good use case. It's a valid use case, but it's not what I was saying. I did say, and I repeat, right now I want to model what people are saying. Using calculation prediction is a bit out of scope. On the other hand, right now I'm trying to understand what is an argument and what is a basic argument, and we speak about the relationship between claims, right? There's overlap, there's containment. This is a variation of this is included in. I think those are important things to model for the user, saying, if you believe that, you have to believe that. Like if you believe the jelly beans are between 999 and 1001, well, you certainly believe they can be between 900 and 1100. It's because it's a subclaim. If you believe one, you have to believe the other. So those are claim equivalence relations that are important. Now, we spoke about arguments, relations between arguments, right? And especially the interesting cases where there's an argument is at first in my mind was, I believe given these inputs, I expect this output. Given this basic situation, which is this and this happening, then I believe this will happen. And I've said all the time, this is a row in the truth table, and maybe it's interesting to know about a related argument, which is a row on the same posits, right? If this is true, this is true, this is true, this is true, this will happen. If this is true, this is true, this is true, this is false, this is true, well, then this will happen, and all the combinations of true, false, right? So, and what will happen in each of the variations on those basic same elementary claims? Because it's about understanding how those premises impact the conclusion. And I want to be able to speak about that. Now, in the case of causal modeling, we cannot take it purely one row at a time because it's ridiculous. Because sometimes if I believe, for example, that the temperature increase will be some constant times the CO2 quantity, it's ridiculous to take, well, if the CO2 quantity is 10 megaton, then the temperature increase will be 0.1 degree. If it's so many megatons plus 1, then it will be 1.01 degrees, and have them as separate arguments. That's absurd. We just want to come up with the constant and the formula and the equivalence and be able to speak about the formula and say all these variables are part of the same argument. And being able not necessarily to use a calculation, but to speak about this family of exact situations are falling under the umbrella of the same model, without referring to the possibility of doing the calculation even, but just saying we're speaking about the same model, and there's this relationship between, in this situation that happens, in that situation that happens, in that situation that happens, and that is all essentially the same argument, or variations on the same argument, or parametric variations on the same argument. Now, is doing the math part of the model? Maybe, maybe not. Maybe that's another bounded context. But saying that all those situations are basically variations on the same theme, for me, I think that's something I want to be able to speak at the user level, to say the user is making an umbrella argument about relation between certain situations and consequent situations, and those are the same argument. And again, maybe it's false, maybe we can talk about compare, competing models, competing this, competing that, that's another story. But saying all those situations and their expected output, those relations, it's the same argument. And so the generalization from truth table row to the whole truth table, how do I generalize that in thinking about this specific instance of the formula, f of this specific x, y, z is this specific w versus the formula as a whole? That's what I'm trying to think about, because I think this is something that, as a user, I want to know, are we speaking about the same model here or not in all those versions? Does that make sense?
So as I commented in chat, I think, if I understand correctly, you are talking about argument schemes in formal logic. Like, for example, an argument from expert opinion would be one thing you're pointing out, and then in propositional logic, you're just referring to a mathematical formula, basically.
Yeah.
Right?
Right.
So you're looking for an abstraction to represent both of these and model these.
Yes.
Yeah, I think it's a useful thing to do on an argumentation level, but I do think the reason for doing that is either like to to let people, well, teach people about types of reasoning, for example, or to tell people, well, if you believe all of these, and then the question is, does that mean that they are forced to also believe the conclusion from that argument scheme, or the outcome of that logic, or they can still disagree with the outcome? And then that's more of that's the next question. But the mere fact that you want to model these things at some point, I think, yeah, makes perfect sense. And if you can find an abstraction for these two, even better. But I think that's a tricky bit.
It is.
I have a response to the what happens if people disagree with it, which is it's an extension of the the feature that has been thought about a lot before, which is you know, the use case of finding internal contradictions, right? You said you believe that, and yet you don't believe this. How is that? And if you have a much more complex truth table or whatever, it's like, your belief about this doesn't match up with what logic would say, right? Why is that? It's the same sort of, yeah,
well, or the logic that somebody ascribed to it, because you also need to agree with the logic, obviously. So
right. I mean, then the argument could be, I disagree with this logic table, essentially,
exactly.
right?
Yeah.
We're missing a factor here or something.
Yeah, you know, I'm thinking a lot about your Tim's argument about the cost of lockdown. I think I like the primary use case. If somebody makes an argument like that, identify that, as I said, there's implicit in there prediction range on the cost will be this much, the lives lost will be this much, and the equivalence factor is this much. And being able to say those three quantities are unspecified and need to be specified for this statement to make sense. And for me, part of the modeling effort is to make it clear. If somebody makes the statement, I want to formalize it, progressive formalization. Well, my formalization would include the notion that these are variables whose values need to be specified. For me, that's a goal. And
that's a really interesting use case, yeah. And it's also the main reason how argument schemes are applied in formal logic. The main reason they're being documented is exactly for that reason. If you have an argument, then you have all the ways of what is missing, filling the gaps, and all the different ways it can be attacked. Templated.
Exactly.
Yeah.
And that way, it's a purely in domain. And the math of that is outside of domain, but being able to understand, like, when does there's a discrepancy in the math model. Like, for example, I often gave the example of is when we speak about these factors are contributing, right? Is necessary versus sufficient condition versus contributing factor. Like, if A and B contributes to C, are they contributing linearly or non-linearly? Meaning, if A happens, it makes C a bit more likely. If B happens, it makes C a bit more likely. Do those probabilities sum up, or does the combination of A and B make C more likely above and beyond the combination of each factor? That's a valid question.
It is in formal logic. I think that the risk, the mistake you might be making is that all of that can also be applied on informal logic. Again, I keep iterating, it is different. I don't know of common abstractions that try to unify them that have succeeded. Informal logic has split off from formal logic because they didn't manage to model actual real world argumentation. Doesn't mean that formal argumentation is non-existent. You can do it, but there are different types of arguments. And I'm not certain modeling them in a unified way makes sense. So I would want to support both in a core model for argumentation, I would argue. But I think it might be more convenient to have them as two separate models. Unless I can see a convincing abstraction, of course, that unifies the two, but I have not seen it yet.
Very interesting. Would you think of argumentations? You think of argumentation schemes as informal, right?
Yeah.
So the question is, can I express the argumentation schemes in my system?
Which in a formal way, can you explain formal in, yeah, I don't know, or in a new way of, because I mean, both of these are already abstractions that exist, right?
Yep.
And for me, what is common is that they model logic. They model like more intricate, logic, more intricate ways arguments work.
We're all like, logic is what we do, right? I mean, we do it informally, yes, and we are not using formal logic in the way we speak, but the basic notion of implication, consistency, negation, those are all fundamental human operations. I mean, we cannot think without those.
Yeah, but
and every argument
when applied
uses
informally,
those.
when applied informally, they're not the same as when applied formally.
That is a fact. That is a fact. But I'm not denying that. But I'm saying, on the other hand, logic was a formalization of basic language operators, and this is still what we want to model. Those basic, like negation. And yeah, I agree with you that
negation actually is formal logic. It just so happens to be one that I find very important because.
But it's formal based on informal. I'm sorry. There is an informal negation that is the basis of formal negation. And yes, they're not identical because.
No, there's formal negation, which is exact negation, which presumes that you have fully defined a claim to its minute level, that you can calculate an exact negation. Then you have informal negation, which when people say not something, or they say just something, the informal interpretation will fully depend still on context, etc. But you can try to minimize that by having more simple claims. That's what I decided to do. But that even between a simple not operator, I would argue it's not the same.
There, and by the way, there I'm with you totally. The not operator of formal logic assumes fully defined terms, and in informal logic, it's up to where we're at in defining terms, and terms are not fully defined, and that means negation is negotiated because the terms are negotiated all the time. And that's the whole point of progressive formalization. There, I'm totally with you.
Yeah, I mean, from use cases, very often, I noticed like people are very bad even at identifying negation, because I try to enforce formal negation in my informal model, knowing fully well that doesn't fully work. But still, you want to avoid saying that the earth is flat is the negation of the earth is round, right? But stuff like that informally feel very natural, and people will quickly make that mistake.
Right. Okay, we're at the hour. I don't know if we progressed so much, except maybe in making our goals clearer. And for me, that's a gain.
Definitely helped me to understand it more.
What?
It definitely helped me to understand the whole thing a bit more.
Okay. I think I'm still standing by that the notion of containment and overlap are fundamental operators, and I don't know if I have buy-in on this, but I'm certainly still proposing those as fundamental operators on fundamental claim relationships. The question of how much do we need to appeal to the actual computation to model what I think is important to model, which is the structure of when is that a profoundly different claim, when is that just a variant? And the notion that, the variation, there's all kinds of axes of variation. It's with respect to a certain numbers of variables that we want to know. Okay, what are the variables that we did vary between those two claims? And maybe I want to make that explicit, or have those claims, although they totally disjoint and totally different claims, being able to express that. How much do these claims have the same structure in common? And I'm arguing it's not there's one structure in many variables, but there's how much of the structure did we make vary? That's an intuition I want to push forward. I'm not fully sure on that, but I want to lay it out there as a question for you all. I think it's important to know when discussing the relation between claims.
Intuitively, I agree something along akin to contained in an overlaps is probably very useful and can support many use cases, which have to do with the common, like how do you spin off and stuff like that, and how do you model the relationships between them. Like a simple use case as I want to see all more specific claims in more specific context might benefit highly from having like overlap relationships modeled. So I'm just not certain that these two are the way to go. But I think I agree with you. They need to be modeled in a way, and it will probably be one of the core use cases, because the whole spin-off discussions keep coming up. The generic specific, I think it's related.
Yeah. Thank you. Tim has to go. I think, is this a good close point? Any last comments?
Seems good. Yeah.
Okay.
See you all.
We'll continue this
Thank
next
you,
week.
everyone.
Ciao,
See
ciao.
you.
Thank you.